class, this is lesson 6.6 about trapezoids and kites. We are going to learn to verify and use properties of trapezoids and kites. Go ahead and try the vocabulary and check back for your answers. All right, let's do this first. Let's go over the theorems of trapezoids. And this is specifically about isosceles trapezoids. Now, we got to remember what a trapezoid is. A trapezoid is a quadrilateral with one pair of parallel opposite sides. So here we have some theorems. Quadrilateral is an isosceles trapezoid, and each pair of base angles is congruent. Trapezoid has two sets of base angles, has actually two bases. This is a base, call it base 1. This is a base, base 2. So, and if quadrilateral is an isosceles trapezoid, then its diagonals are congruent. So if TRAP is an isosceles trapezoid with bases RA and TP, then angle T is congruent to angle P, and angle R is congruent to angle A. All right. So we can draw some congruent marks, right? There and there, and there and there. All right. If ABCD is an isosceles trapezoid, then AC is congruent to AB. If ABCD is an isosceles trapezoid and AB is equal to 5, then CD is equal to 5. And we can label we know that this line here is congruent to this line here. And so we can say that that line and that line are congruent, and that line and that line are congruent. All right. So let's go back now. We also have a trapezoid mid-segment theorem. Now this doesn't have to be an isosceles trapezoid, but one thing, the mid-segment is parallel to the bases, and the length of the mid-segment is half of the sum of the length of the bases. So if TRAP is a trapezoid with mid-segment MN, then segment MN is parallel to segment RA, is parallel to segment TP. MN is 1/2 of RA plus TP. All right, let's go back to problem 1 now. RSTU is an isosceles trapezoid and measure of angle S is 75. What are measure of angle R, measure of angle T, and measure of angle U? Well, we know that the measure of angle R is 75. And we also know that the measure of angle R plus the measure of angle S plus the measure of angle, actually we can just say the measure of angle R plus the measure of angle U equals 180, and that's because RS is parallel to UT, and so same side interior angles are congruent. So 75 plus the measure of angle U is equal to 180. So the measure of angle U is equal to 180 minus 75, which is 105. And once we know that that's equal to 105, then T is also 105 because it's an isosceles trapezoid. All right, go ahead and try the next problem. I need to change some things for you here. We're going to change this to, well, this first one's okay. So in the diagram, measure PQRS of an isosceles trapezoid, and the measure of angle R equals 106. What are the measure of angle P, measure of angle Q, measure of angle S? So the measure of angle Q plus the measure of angle R is equal to 180. And the measure of angle R is given as 106. So we'll substitute that in, and we get the measure of angle Q is equal to 74. And then since it's an isosceles trapezoid, we can fill in the other side. In problem 1, if C, D, E, F were not an isosceles trapezoid, would C and D still be supplementary? Let's change that to if PQRS, and then we can use the same PQRS were not an isosceles trapezoid, would angle, say, Q and angle R still be supplementary? Explain. So would you still have the two angles add up to 180? And the answer to that is yes, because by definition of a trapezoid, there's one set of parallel lines. So given that those are parallel, we can think of this as a transversal or this as a transversal. And so same side interior angles would be supplementary. Same side interior angles are supplementary. All right, let's go and try problem number 2. What are the values of x and y in the isosceles triangle below if DE is parallel to C? So we know that 32, this is an isosceles triangle, so the base angles are congruent by the isosceles triangle theorem. So I can say that 2y plus 32 is equal to 180, and that's by the triangle angle sum theorem, combined with the isosceles triangle theorem. And then if we subtract 32 from both sides, we get 2y is equal to 148. That's from the subtraction property of equality. Divide both sides by 2, and we get y equals 74. And then we can say that x plus y is equal to 180, and that's by same side interior angle theorem. And we know that y is 74, so x plus 74 is equal to 180. And if we subtract 74 from both sides, we get x is equal to 106. Go ahead and try the next one. Check back for the answers. All right, to use the mid-segment of trapezoid W, X, Y, Z. What is X? Okay, there's a theorem, a mid-segment theorem of the trapezoid that we saw earlier. We can use that here. We know that TU is 1/2 of the sum of the bases. So So we're going to write for this one, 18 plus 6x minus 12 is equal to 2x plus 10. And that's by the trapezoid mid-segment theorem. Not quite. We need to multiply that sum by 1/2. So here we go. All right. So then we can simplify it and we get 1/2 6 plus 6x is equal to 2x plus 10. And using the distributive property, we get 3 plus 3x is equal to 2x plus 10. Subtracting 2x from both sides, we get 3 plus x is equal to 10. Subtracting 3 from both sides, we get x equals 7. And let's just check that out. If x is 7, then this is 30. And this is 24. And 30 plus 18 equals 48. And 24 is half of 48. So that all checks out. All right, go ahead and you try that. See if you can fill in the reasons. You can check back for the answers. All right, a kite is a quadrilateral with two pairs of consecutive sides congruent and no opposite sides congruent. If ABCD is a kite, then AC is perpendicular to BD. So, using that information, we know that this is congruent to this, and this is congruent to this. We also know that all of these are right angles. And if we think about it, we have two pairs of congruent sides. So this is congruent to this, this is congruent to that. And of course, AC is congruent to itself. So, so these two angles must be congruent by corresponding parts of congruent triangles are congruent and side, side, side. We get a lot of things there. All right, so quadrilateral ABCD is a kite. What are the measures of angle 1 and the measure of angle 2? Okay, so, well, the measure of angle 1 equals 90 degrees because the diagonals are perpendicular. And also we get the measure of angle ADB. ADB is equal to 40. And that's because these are congruent, so that's an isosceles triangle, and by the isosceles triangle theorem, the base angles are congruent. And so the measure of angle ADB plus the measure of angle 2 is equal to 90, and that's by this is a 90-degree angle, so the triangle exterior angle theorem tells us that the opposite angles add up to that angle. And ADB is 40. So the measure of angle 2 is equal to 50. All right.